of these questions on indices. Now, solutions. The first one, we have 4a raised to power 3b times all in bracket 3a b raised to power minus 2. Now, let's solve these questions. We have this question here. Look at which implies that I told you something. Any power outside this bracket, when we have all one base, it belongs to each of the what? Each of the coefficients and the base there. Any power outside bracket belongs to everything inside bracket, unless it is positive and negative that it doesn't belong to any one of them. But note something. Any power outside bracket belongs to everything inside the what? Bracket, according to the hint I gave to you. So which implies 4a raised to power 3, we have b, there's an invisible one here, times, we have, now look at 3 raised to power minus 2, which implies 3 raised to power minus 2, a raised to power what? Minus 2, which is a raised to power minus 2, and our b also raised to power what? Minus 2. Now, we have this now. We'll now take it one after the other. Those ones that belongs to each other. Now at first, we can take it like this. 4 times 3 raised to power minus 2. We have a raised to power 3 times a raised to power minus 2. And we have b raised to power 1 times b raised to power minus 2. That is what we are going to do one by one. So which implies, let us put in bracket 4 times 3 raised to power minus 2. The next one in bracket, a raised to power 3 times a raised to power minus 2. The next one which says b raised to power 1 times b raised to power minus 2. Now let us, you see, we take them one after the other. So in this instance, we solve 4 times, now this one which implies, whenever you have minus now, it implies that there's an invisible one here. So to eliminate this minus now, you tell them 1 should come up and 3 raised to power 2 should come down. 3 and its base should come down. In this instance, we can apply the first law of indices here, which says that whenever we have the same base multiplying each other, you take one of the base and the power will be what? Added. In this instance, they have the same base of a. We take one of those a. Since they are multiplying each other, the powers will what? We add up each other, which says what? 3 plus, and this power has what? Minus 2. And the next one here, they have the same base, which says the first law of indices, which says that whenever you have the same base multiplying each other, you take one of the base and you add up the power, which says b raised to power 1 plus minus 2. Now, in this instance, we have 4 times 1 over 3 raised to power 2. It means 3 raised to power 2 means 3 times 3, which implies 9, which is 3 raised to power 2 is 9. In this instance, we have 3, which says plus times minus will give us what? Minus. We have minus 2. And in this instance, we have b raised to power 1, which says plus times minus will give us what? Minus. So we have minus 2 here. So in this system, we now say 4 times 1 will give us what? 4 all over what? 9. So we have this. And in this place also, we can tell them that a raised to power 3 minus 1 will give us what? 1. Here also, when we have b raised to power 1 minus 2 will give us what? Minus 1. So the next thing here will now be, look at, bracket still implies 4 all over 9. Bracket implies times, which means times a raised to power 1 times b raised to power what? Minus 1. Because that is what bracket implies. Now in this instant, we can now continue equals to, now look at it. We can say that 4 all over 9 times a raised to power 1. When we have negative power, you tell them there's an invisible one here, because in mathematics it's assumed that all alphabet or all numbers has an indivisible division of what? 1. Which implies when we want to eliminate this minus, you will tell them that 1 should come up, will now be 1 all over b raised to power 1. So here you can tell them there's an invisible one here also. So in this instant, equals to, Now say 4 times A times 1 will give us 4A all over 9 times 1 times B will give us what? 9B. So this is our what? Answer. Or you can write the answer like this as 4A all in brackets 9B raised to power minus 1. So you can write the answer like this or like this. Or even though you can decide to write the answer like this also by saying that since we have this, which implies 4 all over 9 A and we have B raised to power minus 1. So anyway you want to write the answer, you can accept this, you can write this, and everything is being what? Accepted. Number two. Number two says square roots all in brackets 1, 125 raised to power 2, close your bracket, all raised to power minus 1 all over 3. Now, earlier before, I said that look at these roots. It still implies, if you want to put it in power, it still implies 1 over 2. Look at, from the int, which I said, whenever you have square root of x, there's an invisible and you can tell them that is what? X raised to power what? Because it's square root, x raised to power 1 all over what? 2. Because the denominator will become a root and the numerator will still remain as the what? Power of the base. So in this instance, so we can easily say that equals to roots 125 raised to power 2. Because I said bracket is still same thing as times minus 1 all over 3. Now, because this bracket implies times, that was why times the base, I mean the powers there, equals to the square root of 125 raised to power 2 times minus 1 will give us what? Minus 2 all over what? 3. Can you see that? Equals to, and I told you something earlier, that is, whenever we have the square root of x, it implies x raised to power, there's an invisible one here, it implies x raised to power what? 1 over 2. So from the int in which I gave. So in this instant, the square root of this square root will become 125 raised to power minus 2 all over 3. Now these roots will now become times as the power, will now become 1 over 2 as the power. I hope everybody is getting what I'm trying to say now. That is, whenever we have the square root of x raised to power 1, it implies x raised to power 1 over 2. That is, the square root of this becomes what? 1 over 2. Because don't forget, the denominator will become a root, while the numerator will remain as the what? As the power. Do you get my point now? So in this instant, that is what, whenever you see the square roots here, whenever it's square roots, it will be times 1 over 2. So in this instant, you can say equals to, that is, you can say 2 here 1, 2 here 1. In this instant, we have 125 raised to power minus 1 all over 3 times 1 all over 1. So from here, you can say 125 raised to power minus 1 times 1 is still given as minus 1, and 3 times 1 will give us what? 3. So in this instance, we can decrease 125 into the lowest base of 5. Look at it. 125. What can go in 125 without remainder? Can 2 go in 125 without remainder? No. Can 3 go in 125 without remainder? No. Can 4 go in 125 without remainder? No. So, but 5 can go without remainder. 5 in 125 will give us what? 25. And 5 in 25 will give us 5. And 5 in 5 will give us 1. So, which implies 5. How many 5? 1, 2, 3. Which is 5 raised to power 3. So, here, to decrease 125 to the lowest base will now be 5 raised to power 3. 5 raised to power 3 will give us 125 times minus 1 all over 3. So in this instant, 3 can cancel 3. So what do you have? You have 5 raised to power, what do you have here? Minus 1. So which implies, whenever you have negative, you can write your answer as 5 raised to power minus 1, or you tell them that whenever you have negative 1 here, you tell them that all in mathematics, all numbers has an invisible division of what? 1. So we said 5 divided by 1 is still the same thing as 5. So in this instance, when you eliminate this minus, you tell them 1 should come up and 5 raised to power 1 should come down, which equals to 1 all over. 5 raised to power 1 is still the same thing as 5. So you can write the answer as 1 over 5 or 5 raised to power minus 1. You get it now? So that's the answer for question number 2. So we are solving for number 3, which says 16 raised to power 3n all over 4 divided by 8 raised to power 5n all over 3 times 4 raised to power n minus 1. So look at, first thing you first sight on, that you can easily decrease everything to the lowest base of 2. Now 16 can be decreased to the lowest base of 2. 8 can be decreased to the lowest base of 2. 4 can also be decreased to the lowest base of 2. Now in this instance, look at it. 16 first. We are taking it for 16. What can go in 16 without remainder? 2 can go. 2 in 16 will give us what? 8. 2 in 8 will give us 4. 2 in 4 will give us 2. 2 in 2 will give us 1. So how many 2 do you have? We have 2 raised to power 4. That's for 16. Now for 8 in this instance. 8. What can go in 8 without remainder? 2. 2 in 8 is what? 4. 2 in 4 is what? 2. 2 in 2 is what? 1. So in this instance, let us look for what? 4 also. 2 in 4 will give us 2. 2 in 2 will give us 1. Which implies for 8, how many 2 do we have being used? Which is 1, 2, 3, which is 2 raised to power 3 will give us 8. And 2 raised to power 4 will give us what? 16. While 2 raised to power 2 will give us what? 4. Now, these are the numbers, the base you can decrease the following number. 16 can be decreased to what? 2 raised to power 4. So we have 2 raised to power 4 times its initial base, its initial power, which is times 3n all over 4, divided by 8 also can be decreased to the lowest base, which says 2 raised to power 3. So we have 2 raised to power 3 times 5n all over what? 3 times its initial power times we have 4. Oh, sorry. 4 can be reduced to the lowest base of 2, which says what? 2 raised to power 2. This one times in bracket. This one I'm making this one in bracket because there are 2 what? These are numbers, it involves 2 numbers in one, which is n minus 1. So let us move on. In this instance, now say 4 can go in 4. You have 1, 4 here 1, 4 here 1. So 3 here 1, 3 here 1. Now in this instance, we now say 2 raised to power, what do you have left here? 3n divided by 2 raised to power, what do you have left here? 5 raised to power n times 2. Now look at 2 times 2 multiply everything inside this bracket. 2 times n will give us 2n. And 2 times minus 1 will give us what? Minus 2. So in this instance, everything are all in the same base. So from here, with this one, we says this one will follow because they said 2 raised to power 3n divided by 2 raised to power 5n. This one follows the second law of indices. Why this one follows the the first law of indices, whenever we have the same base multiplying each other. So in this instance, they all have the same base. Now which says equals to 2 raised to power 3n, because when the second law says that whenever we have the same base dividing each other, you what? You take one of the base and you subtract the power, which says 2 raised to power 3n divided by 2 raised to power 5n. When it is divided, the power will what? Subtract minus 5n. This one now times, when the power base are multiplying each other, the power will add up each other. Plus, you need to make this one in bracket 2n minus 2. Look at it, because the reason why these things now is just a single number. So it's just a single number. That was why I'm making it in what? In bracket. So in this instance, we have it here. Let us open up the bracket there. We have 2 raised to power 3n minus 5n plus times 2n will be plus 2n. Plus times minus 2 give us what? Minus 2. Now, in this instance, let us continue here. So we have equals to, you can tell them that, you can tell them 2 raised to power 3n minus 5n will give us what? Minus 2n. Look at it. We say, let me take it one by one. 3n minus 5n will give us what? Minus 2n plus n minus 1. So in this instance, we have 2 raised to power minus 2n plus n will give us what? 0n minus 1. So in this instance, you can say equals to 2 raised to power 0 minus 1 will give us what? Minus 1. You can stop your answer as 2 raised to power minus 1, or by inputting that there's an invisible 1 here, because any number in mathematics has an invisible division of 1. So to eliminate this minus, you tell them that 1 should come up, this 1 down should come up, and 2 raised to power 1 should come down, which implies 1 all over 2 raised to power 1 is 2. So you can write your answer as 1 over 2 or 2 raised to power minus 1. So please, we are going to stop here in today's class. The rest of the example will be solved in our next class. Please don't forget to subscribe on our YouTube channel. Please like our videos, share our videos, and please continue whenever we drop videos to watch more of our videos in order to continue with our class and know more mathematically, statistically, economically, and accountically. So in this instance, please follow us on other social medias by searching for Samson's Tutor on YouTube, on Facebook, on Instagram, and on TikTok. You will search for Samson's Tutor. Like our videos, share our videos, and please subscribe to our YouTube channel. So it's just not going to cost you much thing than that of your data to learn more academically. Thank you and God bless you.